All right, 5.6. Make sure you're on 5.6 in your notes. Relate partial products to an algorithm. Now, an algorithm is just sort of a standard way of doing it. Like algorithm, when we add and subtract, is to carry or to borrow. So that's just called a sort of an algorithm. So we're relating partial products to an algorithm. So hopefully by the end, you'll be able to multiply using the algorithm. Now, I do want you to follow along. I do want you to sort of write down what I'm doing. And after you try it, after you practice it, if you still feel more comfortable with the area model, that's fine. This is just a different way to do it. I don't think it's better or worse, just different. So the distance from Los Angeles to New York City is 7 times as far as from Los Angeles to Phoenix. How can you determine the distance from Los Angeles to New York City? Well, there's Los Angeles, there's New York, there's Phoenix. It tells us that Los Angeles to Phoenix is 413 miles. So we're trying to figure out if it's 7 times as far, how much would that be? Well, what equation could we write? Now I could do 413 7 times, like add it together 7 times, or I can do 413 times 7 equals my mystery distance. I don't know how far it is. That's what I'm trying to figure out. Notice it does have that equal sign. That's what makes it an equation versus an expression. So one way to multiply is an algorithm. The definition they give here is a step-by-step method for performing calculations. Okay, so that's sort of the official definition is just the step-by-step method that's been sort of commonly accepted as like a way to do it. So, like it says in your notes, we start in the ones place. So fill in the ones place. And then regroup is what will go in that next blank, because sometimes we have to regroup when we use the algorithm. The regrouping is what makes it a little harder, I think, than the area model. There's just more to hold in your head versus one step at a time. So we start here and we multiply it up here. So 7 times 3. 7 times 3 is 21. So we're going to write the 1, and then we regroup the 2 above the tens place, because it really represents 21. So it needs to go in the tens place. I'm going to erase it, but I will, we'll keep adding on to that. So again, we're writing it in the same spot. So, like that. Then the next step, we're still using the 7. We're doing 7 times this 1, which represents 10, right? So I'm doing 7 times 10, which is 70. And I need to add on the 2 tens, so it becomes 90. So I can write it here. I don't have to write the full 90 because this 1 being here, it's like 91. Or you can think of it as 7 times 1 is 7, plus 2 is 9. It's like we add on what we regrouped. We still multiply, but then we add the top part. So make sure you have that written in your notes. All right, we're going to keep going. Again, 70 plus 20 is 90. Then we multiply the digit in the ones place by the digit in the hundreds place. So we're doing 7 times 400 is 2,800. So I can just write the 28. I didn't have anything to add on that time, so I can just write the 28. And I don't want to write 2,891 because then that's suddenly 280,000, which is not what I want. So I just write the 28. Again, you can think 7 times 4 is 28 when it's really 2,800 because of the numbers that are already there. I'll show some more examples where sometimes we have regrouping, sometimes we don't, but we can see after we do all that, 2,891 is the distance from New York to Los Angeles. So that's sort of the standard algorithm. I'll show you some more. So do this with me. So I start in I always do times the 4. All right, times 4. So I'm going to do 4 times 1 is 4. Now I do 4 times 2 is 8. Nothing to regroup so far. 4 times 0 is 0. 4 times 3 is 12. That one was a little more simple because I didn't have to regroup at all. But I notice how I'm just sticking with, I'm always multiplying by this 4. Like when we had partial products, I need to make sure to get every combination. So I need to get every combo with this 4. All right. I'm going to have you try then. Try using the partial products, or the algorithm, sorry. Try using the algorithm. If you're like, whoa, not feeling comfortable, you can use the area model as well. I'm going to be showing the algorithm on this one just so you can start to see how it works. So 327 times 6, go ahead and give it a try. All right, hopefully you got it. So I'm going to rewrite it over here so I have a little more space. All right, so I'm using my 6. I'm going to do 6 times 7. That's 42. So I need to put the 4 up there and the 2 down here. Kind of like I would if I was adding, right? I carry the tens place, I write the ones place. Now I'm going to do 6 times 2, which is 12, but I need to add on this 4. So it's like I'm doing 6 times 20, which is 120 plus 40 more. So 6 times 2 is 12, plus 4 is 16. So write the 6, carry the 1, just like I did before. Now I'm going to do 6 times 3 is 18, plus 1 is 19. So 1,962. Okay. Let's do another one. 543 times 8. Go ahead, give it a try. All right, hope you got it. Now, each method has its pros and cons. I think this takes up a little less space. I don't have to do all the multiplying and then find room for all the adding. But notice I do have to multiply, hold that answer in my head, add on the next thing, and write it down. So instead of multiplying and adding separate, I do it kind of all mixed together, which can be harder. So just different ways to do it. 3 times 8 is 24. Write the 4, carry the 2. 8 times 4 is 32, plus 2 is 34. 8 times 5 is 40, plus 3 is 43. So notice I had to do like 8 times 5, get that 40, hold that in my brain, and then add on 3, 41, 42, 43. So that's what I mean by I have to sort of multiply and add all mixed together. We have time for at least one more, and then we'll see. All right, 1,931 times 5. Go ahead and try it. All right, hope you got it. And if you're needing more help, if you're needing me to explain slower, that's fine, but make sure you ask. So I have 5 times 1 is 5. 5 times 3 is 15. Notice I write it over the next digit. I just used the 3, so I write it over the 9. 5 times 9 is 45, plus 1 is 46. 5 times 1 is 5, plus 4 is 9. So notice as my top factor gets longer, my answer gets longer, right? that makes sense. All right. Think we'll leave it there. And if you want me to show you more examples, if you're not feeling comfortable, that's fine. If you want me to just give you some problems to work through, that's fine. Otherwise, obviously, you have your whole practice page and you can get help on that. All right. Again, if you're like, I got this algorithm or I want to try it, good. If you're like, wow, that makes no sense, I'm going to go back to the area model. That is fine too, as long as you have a strategy that works for you. Good luck.